Hey everybody, today we're going to be learning about plate tectonics. This is basically the theory of how these plates are interacting with each other. We've done lots of questions and looked at lots of maps on how these plates are interacting with each other and the different features that are created because these plates are interacting with each other. So you should have a basic understanding from doing the discovering plate boundaries activities the last couple of days. But this is basically a summary of all of that, and then we'll have a test here in the next week or so. So you can see a lot of the features that we've been talking about. Here's some volcanoes that are happening on the coast, and then you have a deep ocean trench, which is happening because of a subducting plate. Again, the volcano is also happening because of the subducting plate, because some of that material is rising up because it's less dense, and then forms a volcano. And then we have a section here that's seafloor spreading, which then creates a mid-ocean ridge. We have some islands that are forming. We haven't talked about why that's forming in the middle of the plate. Notice how there's no arrows around here. So we're going to talk about that in the next section of notes. So don't worry about that right now, but know that you will need to know that eventually how that happens in the middle. That's how Hawaii is formed, by the way. Now you also have a subducting plate and a going under another plate, but the thing is over here this is an oceanic plate and an oceanic plate colliding, whereas over here it's a continental and an oceanic colliding. There is a difference, and we'll talk about that. This is happening. An example of this would be like South America. We saw lots of things happening in South America in the discovering plate activity, and over here this would be like in Alaska. So same type of thing is happening. They still are converging. They are still going towards each other and subducting. But the fact that these are oceanic plate and this is an oceanic and continental does change things slightly because of the features that are created. So, what is plate tectonics? Plate tectonics does sound a lot like continental drift. You need to know the difference between plate tectonics and continental drift. They are not the same thing. Keep in mind, Alfred Wegener, he came up with the theory of continental drift. Think about the title of that, continental drift, meaning the continents are shifting. He didn't know that there was an entire plate at the bottom of the ocean that was moving around too. So he thought, for example, let's use Africa. He thought just Africa was shifting around. But in fact, it is not Africa. It's the ocean floor around Africa, part of Saudi Arabia, Africa, and then the ocean floor on the west side of Africa also. So it doesn't just stop on the coast of Africa. It extends out because of that seafloor spreading. So the thing is remember, he didn't know what the force was that was moving and driving these continents from one place to the other. So the theory of plate tectonics states that there is a geological theory that states that pieces of the Earth's lithosphere, that's the key here, it's not the continents that are moving, it's the lithosphere in plate tectonics. And they are constant slow motion. And they are driven by, again, another key here, convection currents. Because he did not know, Alfred Wegener, in continental drift, he did not know what was driving driving the continents to move. He just knew that something seemed similar and that they were together at one point. He was right on that end, but he didn't know how they were moving. So this theory explains the formation, the movement, and the subducting of the Earth's plates. And then down at the bottom left, you can see that there's the three examples that you will definitely need to understand: the convergent plate boundary, divergent boundary, and transform boundary. And we'll go into depth here in a moment. So at each of the plate boundaries, there are things called faults. So this first feature is called a fault, and this is a break or a crack in the Earth's crust where the plates have slipped past each other where plate boundaries are. So here's a plate boundary here. This is out in California. This red line right here is a plate boundary. And this is actually called the San Andreas Fault. Here's another picture of it, an actual picture of it. And you can see how they're slipping past each other. The arrows are not moving towards each other. So it's not like this arrow is moving this direction and this arrow moving this direction. They're slipping past each other like they're passing each other in the hallway. They are transforming, okay? They are transform boundaries, okay? So anytime you have a plate boundary, there sometimes will be a fault where those plates are sliding past each other because it then creates a crack in the crust, okay? Think about if you were to take a York peppermint patty and you were to break it in half, it would create a break. So that's all what a fault is. It's just that crack in the crust. A convergent boundary is our first boundary that you will need to understand. This is key. This is like the biggest section of these notes. So make sure you understand the convergent plate boundary, because there are 3 parts. Count them. 1, 2, 3 parts to convergent plate boundary. This is just the first one right here, okay? So a convergent plate boundary is a plate boundary where 2 plates move towards each other. Think about it. If you're going to converge with somebody in the hallway, you're probably going to, that means you're going to run into them. Convergent means to collide. Convergent, collide. So if you want to write that down, if you are writing something down, please write that down somewhere, okay? It is very helpful. It's one of my silly ways to remember something. So convergent, collide. Now, sometimes one plate will go under the other. So this is kind of something we've already talked about. So when one plate goes underneath the other, we call that subduction. And this plate right here goes underneath of this brown plate because it is more dense. So it sinks. Okay. Now this is a continental plate. This is an oceanic plate. And how do we know that? Well, 1, it's thinner. And 2, here's the ocean. And it says sea level right here. So the oceanic plate is more dense. So therefore it is going to sink underneath of the continental plate. That always happens. When oceanic and continental collide, the oceanic goes under the other. And so let's go into more depth with that thought. Oh, and then here's convergent plate boundary. There's the arrows moving towards each other. So again, if you're writing something down, you can draw 2 arrows moving towards each other. That will be helpful much later on. This is like in the Avengers in Civil War. They were fighting. They were going towards each other. They're going to collide. Okay, so and they end up fighting. But right, Wakanda forever. Okay. All right. So there's 3 different types of convergent plate boundaries. Here are the first 2. The first one is oceanic and oceanic, which means this is an oceanic crust and this is an oceanic crust. When this piece of crust and this piece of crust collide with each other, the one that is older is more dense and therefore will sink. So this is the older crust, so it sinks. Okay. So the subduction occurs, and then also when it sinks, you should know what happens when subduction happens. That forms a trench. And then there's also, this is a new little piece of information, that volcanoes will then form. Because when subduction happens, there's some material that then will rise up and then bubble up through the surface of the younger crust and then form a volcano. And that volcano then eventually will build up, and form a little island. Isn't that like a cute little island? Now, this is an example, if you're going to be writing things down, like up in Alaska. You know how Alaska has that little tail that's hanging off of it? Well, that's an island arc. This is an example of an island arc. And there's many other examples, but I like to use that one because it's somewhat close to where we live. So this is one example of how oceanic and oceanic can form a couple different features. So the 2 main features that it forms is an island arc and a trench. So if you're writing something down, please write that down. There's a lot to know here, so I would suggest writing things down. Now you have oceanic and oceanic up here. Now we are going to move on to oceanic and continental when they collide. So you have an oceanic crust. Again, you can tell because there's water right here, and it just says it's oceanic crust. It's colliding with a piece of continental crust, and you can tell because it's above water, and it says continental crust. This continental crust is colliding with the oceanic crust. See the arrows, now they're moving towards each other. But the oceanic crust is more dense, so therefore it's going to subduct, and it will then do the same thing as we saw up here. It's going to form a volcano, except this volcano is not going to be an island arc because it's not in the middle of the water. This is only called an island arc because it's 2 oceanic plates colliding, and islands are in the middle of the ocean. Okay, so this is going to just form a volcanic arc. Okay, so this is just volcanoes. An example of this would be like the Andes Mountains or the Andes volcanic mountains. So this was seen in the discovering plate boundaries. We saw lots of things happening with the Andes Mountains. There was lots of earthquakes, volcanoes. You saw those subduction zones happening there. So that you should, and the Andes Mountains, by the way, are in South America, on the west side of South America. So this is where subduction is occurring. Again, it forms a trench and a volcanic arc. So you can see an arc of volcanoes. Okay. And an arc means it's a line of volcanoes. Again, here, a line of islands. Now, our last one that we need to understand for convergent, this is all still convergent plate boundaries, is when a continental and a continental plate collide. There is no subduction, okay? There is the two plates collide and they smash into each other. Imagine taking a loaf of bread and you put your hands on both sides and you smush it together. It's going to form a ball. It's going to be higher up than it was before. Okay, if it's sitting on the table, you smush it together, the bread's going to go somewhere. It's not going to go underneath of itself. It might fold a little bit, but when that folding is happening, that's not subduction. This is when mountains are formed. This is how above India and above India is the Himalayan Mountains. So this is how the Himalayan Mountains formed. When those two continental crusts collided, it forms a mountain range. Okay, that's the only thing that happens here. You need to understand, though, that there's no subduction and there's mountains that are forming. There's a little gif of that happening. All right, so that was all convergent plate boundaries. Now we're going to move on to divergent plate boundaries. A divergent plate boundary is where two plates move away from each other. Okay, if you've ever seen the movie Divergent, okay, or read the book, you know that I forget the character's name, but she is going away from everybody else. She's not going with the crowd. She's going away from the crowd. So these are like two plates that are moving away. They're divergent. They are dividing. So convergent collide, divergent divide. Okay, I'm trying to help you remember these things. So divergent divide. They're going to move apart. Now, we've talked about these. We just didn't use this word divergent. This is where two plates move away from each other. That kind of sounds like something we've learned before. Seafloor spreading. This is where mid-ocean ridges occur. But it can also happen on land. And if it happens on land, it's not a mid-ocean ridge. We call this a rift valley. This is a new vocab word. You need to know this. This will be on the test. It's called a rift valley. So again, if you're going to draw arrows, go ahead and draw arrows of divergent plates moving away from each other. So here's an example of a rift valley. We haven't gone over that. I'm not going to show you a mid-ocean ridge because we've done so much. I'm sorry, yeah, mid-ocean ridge, because we've done so much of a mid-ocean ridge. You should know what a mid-ocean ridge is. So with a rift valley, in this top right diagram, you can see if it's in the ocean, that you can see if it's in the ocean, it makes a mid-ocean ridge. So two oceanic crusts colliding or dividing, and then it will move further and further apart. But if it's on land, like in Africa, there's a big giant rift valley called the East African Rift Valley. So this is when it's on land and it's dividing, and as it gets further and further apart, you can see eventually this valley will get so deep it's below sea level and water will start to collect. So this molten material will come up and form new land, and then it will keep pulling apart this section of Africa right here. So maybe over time, this section will become its own little island, kind of like Madagascar is. This is a picture of me in 2013 at the East African Rift Valley. It's an amazing sight. That's not really me. Our last plate boundary that you need to understand is transform plate boundary. So convergent collides, divergent divides, and transform plates, they slide. So they are sliding away and towards from each other. So they are sliding past each other. I'm sorry, I said towards and away. So this plate right here will move towards you. Like if you were to imagine it coming at your face, this one's going to move away from you. So they're not going to move at each other or away from each other. See these arrows, how they're moving? They're sliding past each other, like they're walking past each other in the hallway, or two cars passing each other on the road. They're moving in opposite directions. Crust is not created here, like at a divergent plate boundary, and crust is not destroyed here, like at a convergent boundary. You need to understand at a convergent plate boundary, crust is destroyed because of subduction. You should already understand that. Whereas at a divergent plate boundary, crust is created. But at transform, none of that happens. Crust is just kind of broken up. There might be a crack. Rocks will crumble. Earthquakes will happen. Okay, earthquakes happen at this one. This is the only thing that happens at a transform plate boundary. But if you think about at convergent plate boundaries, divergent plate boundaries, and transform, they're all giant pieces of earth that are moving and grinding against each other. They're all going to create earthquakes. So when the convergent plate boundaries happen and there's subduction or there's mountains forming, there is earthquakes. If the plates are being pulled apart, that's a giant piece of crust that's being ripped to pieces. It's going to create some earthquakes. Okay, so that is all the plate boundaries. If you were to draw arrows, you would draw them sliding past each other. This GIF kind of looks like that they are going towards each other, but just imagine you're looking down an aerial view and that they are sliding past each other, like cars passing each other on the road. Here's a plate boundary map. I know you're so excited to see another map, but what I wanted to show you here is how these plates are moving. So take a look at these arrows. What do you think that these arrows all mean besides the direction? Why do you think that there are different sizes? So there are different sizes to these arrows because of the speed in which that each plate is moving. So take a look at the South American plate. It's not moving very fast, whereas this Nazca plate is moving really fast right into South America, which then this is oceanic and continental, and they are going towards each other. So what kind of plate boundary would that be? This would be a convergent plate boundary. So this would form a volcanic arc right along here. So if you remember, there was lots of volcanoes here, lots of earthquakes, because look at this activity that's occurring here. And then up here, this was the island arc that I was talking about off of Alaska. So this is because oceanic and oceanic are colliding. Now this is continent right here, but right here, it kind of got cut off. Right here, this is a oceanic plate colliding with an oceanic plate. And so see how these arrows are moving down, these arrows are moving up, and they are colliding into each other, and therefore will make an island arc. And you can see that in several other places in the world. So look, we had lots of subduction zones over here. This is where the Mariana Trench is, and see how this Eurasian plate is slamming into the Pacific plate, and then that therefore will make a subduction zone. So I could go over every single section here. You have the mid-ocean ridge here. See how they're dividing. They're going away from each other in this section. So that would make the seafloor spreading or the mid-ocean ridge at a divergent plate boundary. There's lots of information. We are continually building and building and building on all this. Again, we have a test here soon, so make sure that you're understanding this, reviewing the maps, reviewing lots of the information that I've talked about. And you'll do great if you review all those things, okay? All right, so what is the relatively soft layer of the upper mantle called? What is subduction of the ocean floor? What feature would that create? Would that create a lower mantle, mid-ocean ridge, rift valleys, or trenches? When two plates collide with each other, this happens at the divergent boundary, convergent boundary, a boundary between the mantle and the crust, or a transform boundary. And then what is the process that powers plate tectonics? Radiation, convection, conduction, or subduction? Okay, so in Polaris, go ahead and work through. There's a few other videos and simulations I want you to look at. And then finally, there will be a plate tectonics worksheet that I would like you to work through. All right, have a great day, everybody. And don't forget, make wise choices.